All right, we're about to tackle one of the biggest questions you can possibly ask. Where did all of this, everything, come from? We're going to take a journey, a trip, 13.7 billion years into the past, to dig up the actual evidence for the Big Bang.
But first, let's start with a much simpler question. We all know what happens when you drop an egg, right? It breaks. You can scramble it, but have you ever seen scrambled eggs just, magically pull themselves back together into a perfect whole egg? Yeah, of course not. And that simple everyday fact actually holds the key to a huge cosmic puzzle.
See, on the one hand, there's this fundamental rule of the universe that says things naturally go from a state of order to disorder. But then on the other hand, you just have to look up at the night sky to see this incredible, mind-boggling complexity. So how can both of these things possibly be true?
Well, this principle has a name: entropy. It's basically an unbreakable rule that, given enough time, things fall apart. They move towards chaos. They become, for lack of a better word, mush. It's the reason your hot coffee eventually gets cold, and, yep, why eggs don't unscramble themselves. And that, right there, is the central mystery we're diving into. If the universe's default setting is to break down, then how in the world did it build all of this up? How do we get from some simple, hot beginning to the stunningly complex cosmos we see all around us? This is a cosmic detective story, and we are going to follow the clues. To find our very first clue, we've got to travel back in time. And I mean way back. So let's hop aboard our spaceship of imagination, as the source material puts it, and set the destination for the very, very beginning of everything.
And here's our map for the trip. What you're looking at is the entire timeline of the universe, all the way from that tiny, hot, incredibly dense point on the far left to the vast, sprawling cosmos we know and love today. Our story starts right at the beginning of that flare.
So this is absolutely crucial to understand. The Big Bang was not some kind of bomb going off in an empty room. It was the rapid expansion, like a stretching of space itself. Everything, everywhere, all at once, blooming from a single point of unimaginable density.
And things happened fast. I mean, in the first tiny fraction of a second, the universe inflated at a truly staggering rate. Before even 1 second had passed, the first fundamental particles just popped into existence. By the 3-minute mark, the first atomic nuclei were being forged. But for the next 380,000 years, the whole universe was just this glowing, opaque fog, until finally it cooled down just enough for the very first light to break free and travel through space.
Okay, I know, this is an absolutely wild story, but you've got to be asking, how on earth could we possibly know any of this is true? How can we be so sure that the universe is actually expanding? Well, that brings us to our first major piece of evidence. Our cosmic detective story now jumps forward to the 1920s and to an astronomer named Edwin Hubble. He was busy looking at what he thought were distant nebulae, but he was about to uncover a critical clue that would change everything we thought we knew about the universe. Hubble was using a tool called redshift, and you already know how this works, instinctively. Think about an ambulance siren. As it comes towards you, the pitch sounds really high, right? And as it moves away, the pitch drops low. Well, light does the exact same thing. As a galaxy rushes away from us, its light waves get stretched out, and that shifts their color towards the red end of the spectrum. So, when Hubble started graphing each galaxy's distance from us against the speed it was moving away, the data revealed a pattern that was just wow. It was stunningly clear. The points all lined up, revealing a profound and unmistakable truth about our universe. The conclusion was nothing short of revolutionary. The farther away a galaxy was, the faster it was flying away from us. This wasn't just random movement, this was proof positive of a systematic expansion of the entire fabric of the universe. It's just like drawing dots on a balloon and then blowing it up. Every dot moves away from every other dot. So, boom, clue number 1 locked in. So the expanding universe was a huge clue, but the Big Bang Theory predicted something else too, a faint, leftover afterglow from that hot, early universe. To find that, our search takes us all the way back to that moment 380,000 years after the beginning, to the era of first light.
But how? How could we possibly see that? How could we look back in time and actually witness the leftover heat from the birth of the entire cosmos? It sounds like pure science fiction, but you know what? This discovery was made completely by accident.